If you want the same kind of local-first command layer for agent workflows, check out conductoros.com. Conductor works with the coding agents already in your current setup. It runs fully local, and I'll show the repo plus native coding agent screenshots later in this video. This is one of the more ambitious AI research demos I have seen from Meta. Tribe v2 is a foundation model trained to predict how the human brain responds to almost any sight or sound. Not by simulating random noise or predicting text patterns, but by actually modeling fMRI brain activity in response to visual, audio, language, and music inputs. And the demo is genuinely impressive. In about 30 seconds, it shows the model generating a predicted brain response to sensory input in real time, then benchmarks Tribe v2 against other competing approaches and wins. This is not the kind of AI product that makes it onto the main feed every day. It is not a chatbot. It is not a code assistant. It is something different. It is AI that is trying to understand how perception actually works. Most foundation models today are built to imitate human output. They write text, generate images, create code, and summarize documents. They are very good at pattern matching on language and visual data. But very few of them try to model what is happening inside the brain when a person actually sees something, hears something, or processes language. That is the harder problem, because the human brain is not a language model. It is a multimodal perceptual system that integrates sensory input with context, memory, and expectation in real time. That is the space Tribe v2 is trying to work in. It is a brain encoder foundation model. It does not generate content. It predicts how the human brain would respond to content if you put someone in an fMRI scanner and showed them the same input. That matters because it is a different kind of AI. Most AI systems are built to output something. Tribe v2 is built to predict how the brain would react. Let us walk through the actual clip. It opens on a Meta AI branded screen with a rotating golden brain hologram and the title predicting how the brain responds to sight and sound, with Tribe v2 listed as Trimodal Brain Encoder. Then the clip shifts into live fMRI visualization. A cursor draws a profile on the left side while a colorful brain activation map generates in real time on the right side. Labels show stimulus, model prediction, and music. That live drawing sequence is the strongest proof point in the clip because it shows the model mapping sensory input to predicted brain activity in real time. Next, the visualization expands to show more detailed brain slices with stimulus, model prediction, and music labeled again, plus additional caption overlays reading building predictive systems and coding in your language. A model comparison table starts to appear at the bottom with competing brain encoder approaches. Then the clip shows actual response versus model prediction brain maps, demonstrating that the model can predict what the brain actually does in response to sensory input. The neural pathways become more intricate with cross-hemisphere connections, showing the model is modeling complex brain dynamics. The final frame shows the full leaderboard table with Tribe v2 positioned at the top against competing models. The closing card says, "Find the paper, codebase, and demo here, aidmos.atme/tribe-v2. Open source, private, free to build with." Now, here's what Meta is actually announcing. Tribe v2 is described as a foundation model trained to predict how the human brain responds to sensory input across sight, sound, language, and music. It builds on Meta's Algonaut's competition-winning architecture and is trained on over 500 hours of fMRI data from over 700 participants. The demo shows the model predicting brain activation patterns in real time across multiple sensory modalities. The model comparison table shows Tribe v2 outperforming competing brain encoder approaches. Meta is positioning this as open research. The call to action drives people to a public paper, codebase, and demo site. The research positioning is smart because it makes the work accessible without over-promising consumer capabilities. The strategic lesson here is that foundation models are not just for generating content. They're also for modeling how humans perceive and process information. Tribe v2 matters because it shows that the same transformer-based architectures that power text generation can also predict brain activity patterns. That is a fundamentally different use case from what most AI products are built for. The competitive angle is also interesting. Meta is positioning Tribe v2 as the current leader in brain encoding, and the model comparison table in the demo backs that up. Other approaches exist, but Tribe v2 is shown outperforming them on the leaderboard. The caveat is important though. This is open research, not a consumer product. fMRI prediction is a controlled lab problem, not something that works on a regular smartphone. So the strategic value is in demonstrating what AI can learn about human perception, not in a direct consumer application. And that is also why local-first orchestration matters in our world too. If you want your own command layer for workflows like this, check out ConductorOS.com and the public repo at github.com/sharonix06/ConductorOSS. I'll show the repo, the dashboard, and the native Claude Code, Codex, and Gemini launch screenshots on screen here. Conductor works with the coding agents already in your current setup, and it runs fully local. Different product, same principle. The best systems do not just process data. They model the underlying structure that makes the data meaningful. If you want more breakdowns like this, subscribe. And if you want a local agent command center that works with the coding agents already in your current setup, go to ConductorOS.com and check the open source repo at github.com/sharonix06/ConductorOSS. Fully local, works with your current coding agents, and built for real workflows instead of demo theater.